Hello and welcome to Mind Academy. It's Mert speaking. In this video I'm going to solve three questions: one limit, one differentiation and one integral. Let's begin solving with the first question. So the question asks us, without the L'Hopital rules, calculate the limit as x goes to 0, x plus 4 to the power 3 over 2 plus e to the power x minus 9 over x. So let's call this function here fx. Then the limit can be written in the format of limit as x goes to 0 f of x minus f of 0 over x minus 0, which is f prime of 0. And we can write this form in this format. Since f0 is 0, it would be like limit as x goes to 0, x plus 4 to the power 3 over 2 plus e to the power x minus 9. And I just add a minus 0 here and a minus 0 here, and those don't make a difference. Thus we are asked to calculate f prime of 0, where fx is this function. So I'm taking the derivative, and the derivative of this function here is 3 times x plus 4 to the power 1 over 2 plus e to the power x, and I'm replacing x with 0 to calculate the limit, and the answer is 4. And the second question, use implicit differentiation to find an equation of the tangent line to the curve y to the power 4 minus 4y square equals to x to the power 4 minus 5x square at the point 0 to minus 2. Let's differentiate this equation here. The derivative of y to the power 4 is 4y cubed times dy over dx, because y is a function of x, minus the derivative of 4y square is 8y times dy over dx again, equals to derivative of x to the power 4 is 4x cubed minus 10x. And I'm factoring dy over dx out and sending 4y cubed minus 8y to this side. And I'm substituting with 0 and minus 2 to find the slope of the tangent line. And if I put 0 here instead of x and put minus 2 here instead of y, I find 0. So the slope of the tangent line is 0. And I'm using this format of equation here to find the tangent line. Y minus y0 equals m times x minus x0, where m is slope. Hence the tangent line is y minus minus 2, so y plus 2 equals to, since the slope is 0, this side is all 0, so the tangent line is y plus 2 equals 0. And the last question is an integral question. It asks us to calculate the integral from 1 to 2 ln x square over x cube. In this question, integration by parts should be used, and let's call ln x square u and 1 over x cube dv. Then if I take the derivative of this side, it becomes 2 ln x times 1 over x dx equals, and then this side 1 du. I just disregard 1, and 1 over x cube is dv, and if I take the integral of both sides, then it's minus 1 over 2x2 equals v. Then I'm using this format to calculate the integral u times v minus integral v times du. U here is ln x square times v, just I find here, minus integral v times du. V again is here written, times du. Our du is 2 ln x over x dx. So I just multiply this by this to simplify, and these two minuses make a plus, and this becomes ln x square over minus 2x square plus integral ln x over x cubed dx. So I now have to so calculate this integral, solve this integral. And to solve this integral, I'm again using integration by parts, and let's again call ln x u and 1 over x dv, and take the derivative of ln x 1 over x dx, and take the derivative of u 1 du, and take the integral of these both, and that's the same as here, we just did it. We again use the same format, so I'm just replacing u with ln x times minus 1 over 2x square minus integral 1 minus 1 over 2x square times 1 over x dx, and I'm again rearranging this equation here. Ln x over minus 2x square plus, and these two minuses make a plus again, and the rest is like this. And I now have to solve this integral, but it's just easy. It's this part here, 1 over minus 4x square. So my integral here becomes this. Here I found ln x square over minus 2x square, it's here, and ln x over minus 2x square, again I found it here, and this integral is this number here. And from 1 to 2, the rest is just calculation. If you replace x with 2 and calculate, minus if you replace x with 1 and calculate, and the answer is here. Thank you for watching my video. If you have liked this video, please don't forget to subscribe and like this video to support me.